Hello, grade 7. Welcome to our virtual school equivalent ratio. I hope you still remember our previous lesson about ratio. So if we refer to the previous example that we had, we can say the same thing in two different ways. Okay. Say for example, this is our problem. There are 300 computers for 1,200 students. Or you can say, or you can represent this by saying there is one computer for every 4 students. Let's express the ratio as a fraction. Looking at number 1. So we have 300 out of 1,200, or 300 is to 1,200. If we reduce this to lowest term, as you have been doing in fraction, this 300 over 1,200 is also equivalent to 1/4. That means that we can divide both the numerator and denominator by 300 because 300 is the greatest common factor of both numbers. So 300 divided by 300, you will have 1,200 divided by 300, and you will get 4. Okay, so equivalent ratios make the same comparison. So this can also be 1:4. Find an equivalent ratio by dividing. So let's have our first example. If it's 30:90, we can divide both the numerator and denominator of both numbers by 30. And then you will have 1:3, or 1/3, or 1/3. Another example, if you have 15 out of 12, this is an improper fraction, but since we are doing ratio, we can divide both numbers, both the denominator and numerator, by 3. So 15 divided by 3 is 5, and 12 divided by 3 is 4. So it's also 5:4. Third example, 125 over 300, or 125:300. If you divide both numbers by 25, you will have 5:12. So this is quite similar to reducing your fraction into lowest term. Okay. And we can also call this as the simplest form of your ratio or fraction. Another way of finding equivalent ratio is by using multiplication. Example number 1, for multiplying, which is our number 4 example. If you have 10:4, or 10/4, if you multiply both numbers by 5, you will have 50/20. That means 10:4 is equivalent or the same as 50:20. Fifth example, and using multiplication to get equivalent ratio. For 7 out of 3, you multiply the numerator and denominator by 12, you will get 84:36. 7:3 is equivalent to 84:36. 7:3 is the simplest form or the lowest form. Okay, last example for multiplication. 11 out of 20, you can multiply both numbers by 6. Remember that I'm just getting random numbers. You can multiply your fraction or ratio by any number and you will get equivalent fraction. So these are just my choices. So for 11:20, multiply by 6, 66:120. Okay. Now, here's an assessment. Assess yourself if you have understood the lesson. If not, you can go back and watch the video again from the beginning. Okay, which of the following pairs of ratios are equal? You have to say yes if they're equal, or no if they're equal, or if ratios are equivalent or not. So you're given two ratios in A. Okay, 16:20. Is it an equivalent ratio of 4:5? Check your answer. Should be yes. if you divide 16 by 4, you will get 4. And then if you divide 20 by 4, you will get 5. So these two ratios are equivalent or equal. For letter B, is 3 is to 5 equivalent to 21 is to 35? Your answer should be yes. Okay, because if you multiply 3 by 7, you will get 21. If you multiply 5 by 7, you will get 35. So 3 is to 5 is an equivalent fraction of 21 is to 35. 3 is to 5 is the simplest form or lowest form ratio. Okay, let's move on to letter C. Is 2 to 7 equivalent to 8 is to 21? Let's check. 2 becomes 8 by multiplying 4. So let's try and multiply 7 by 4. 7 times 4 should be 28, not 21. So that means 2 is to 7 is not an equivalent fraction of 8 is to 21. Now, I would like you to pause the video and answer the rest of the questions and problems. And we will check it in the classroom. Okay, to get going, let's now move on to simplest form, writing ratio in simplest form or lowest term. If you're going to express ratio in fraction, it means that you are reducing it to lowest term. Okay, so for example, write the ratio in simplest form that compares the number of scooters to the number of unicycles up here, then explain its meaning. Okay, scooters, you have 4, and then you have 10 unicycles. If we want to get the simplest form, we need to think of a number which is the greatest common factor of both 4 and 10. So it's what is the biggest number that you can use to divide both numbers and you will get whole number. Okay. And that is going to be 2. So you divide both numbers by 2 and you will have 2/5. So this means the ratio of scooters to unicycles is 2/5 or 2 is to 5, 2 to 5. This means that for every 2 scooters, there are 5 unicycles. Okay. Check your progress. Fruit. Okay. Write the ratio in simplest form that compares the number of the oranges to the number of apples. So let's count the number of oranges first. We have 1, 2, 3, 4, 5, 6. So you have 6 oranges and you have 1, 2, 3, 4, 5, 6, 7, 8, 8 apples. So you have 6 oranges to 8 apples. Now, it says here, simplest form. So we need to think of a number, which is the greatest common factor, that we can divide both to 6 and 8, and it should be the highest one. What number should we use to divide both numbers? We can use 2 to divide both numbers, and if we do, we divide 6 by 2, you will get 3, and you divide 8 by 2, you will get 4. So we're looking for 3 is to 4. So that should be 3/4. Okay, now here's another assessment. Express the following ratios in simplest form. So if you're more familiar with fractions, you can rewrite your 2 is to 4 into fraction form and reduce it to lowest term. So let's try 2 is to 4. What is the biggest number that you can divide to both 2 and 4, and you will still get a whole number? So the greatest common factor is 2. Divide 2 by 2 and you will get 1. Divide 4 by 2 and you will get 2. So the answer should be 1 is to 2. For letter B, 10 is to 5. What could be the biggest number that you can divide to both numbers? And the greatest common factor for both numbers is 5. So 10 divided by 5 is 2. And 5 divided by 5 is 1. So that should be 2 to 1. Okay, now check your answer. Now for letter C, 6 and 14. What could be the biggest number that you can use to divide both numbers, but will still give you a whole number? And that could be 2. 6 divided by 2 will give you 3. 14 divided by 2 will give you 7. So your answer should be 3 is to 7. Now I'm going to stop giving you examples here, and I want you to answer and solve the rest of the problems from letter D to I. So pause the video and complete and solve all the problems here on this slide. Okay, express the following ratios in simplest form. Another example. If you're given fractions as your ratio, you can simplify them by multiplying both fractions by its denominator. For example, I will rewrite for letter A, 2/5 is to 3/5. I'm rewriting 2/5 down here, and I will rewrite 3/5 down here. Okay, because the denominator is 5, I'd like to remove this 5 and make the fraction into a whole number. By multiplying that by 5, by both fractions by 5, using cancellation, you can cancel 5 over here and 5 there. Your answer is 2. And 3/5 times 5, you can use cancellation because this is the same as 5 over 1. You can have, and you will have 3. So because you have 2 and 3, the final answer is 2 is to 3. That's your simplest term. For letter B, 1.5, this is an improper fraction. The best thing to do is, this is a mixed fraction. The best thing to do is to make this an improper fraction. So 1.5 is the same as 3/2, and I will write 5 again down here. Okay, the idea is to multiply it by the denominator. Our denominator is 2, so I'm going to multiply this by 2. If I multiply this by 2, I am also multiplying this by 2. Okay, using cancellation, 2, okay, 3/2 times 2 is equal to 3. 5 times 2 is equal to 10. So our ratio in simplest form is 3 is to 10. Okay, again, you have questions here, and I would like you to stop the video and solve the problems here. All the questions and solutions will be checked on Monday when I see you after virtual school. Or I will check your Google document that you're going to send me and write some comments there. Okay, now you will also have to answer the challenge question, and there's a hint here, and I will play it without talking, and I hope you understand, and this will help you solve the challenge question in your book. Okay. So John and Mary make strawberry punch, whose punch has a stronger strawberry taste. This is a similar question that you have in your challenge question. Okay, I hope you understand this last slide. This is a big help when you solve, this will be a big help when you solve the challenge question. Please look at your board, the canvas that is in your web page, to know what you need to solve after this video. I need the answers and solutions for all the questions that are in this video, as well as the challenge question in your textbook. Okay, goodbye and see you in class.